All right, this video is going to go over the test review for test 5B, so let's go ahead and get started. The first part's all exponents. So look at number 1. Anything that has a negative exponent has to switch sides of a fraction. So here's what I mean. Imagine you had like x2 y negative 3 over a negative 4 z 1 or something like that. The things with the negative exponents have to switch to the bottom and then that exponent, or to the top, and then that exponent becomes positive. So the things with the positive exponents, they don't move. But the things with the negative exponents switch sides. So like a negative 4 came to the top and became a positive 4. Y negative 3 went to the bottom and became y positive 3. So keep that in mind as we do these. So like this first one, imagine it currently is over 1. So these things with the negative exponents have to switch to the bottom here. So it's going to end up being B6 stayed on top. A, now it's positive 4. C, now it's positive 9. Just like that. Okay. Now, also with exponents, you need to realize that everything has its own exponent. So if it's not there, it's a 1. And power to a power, you have to distribute this exponent. So you're basically multiplying it. So it's actually like 6 to the 1 times 2, which is 2. X to the 3 times 2, which is 6. Y to the 1 times 2, which is 2. Now it only went to the top. You see how the top was grouped, the bottom wasn't, so the bottom stayed 3x squared. All right, now you just have to simplify it a little bit. 6 squared is 36. Then you have x6, y2 over 3x2. So 36 divided by 3 is 12. I have x6 over x2. So you can basically subtract those or ask yourself which one's bigger, the top or the bottom. The top was bigger by how much? 4. And then I had y2 up there as well. Okay, this next one, give the p its 1, and then you have to distribute this. So it's going to be p to the 1 times negative 1 is negative 1, h to the 5 times negative 1, which is negative 5. And imagine it as over 1. Well, remember, negative exponents have to go to the bottom and or switch sides and become positive. So p to the 1, h to the 5 now on bottom, but there's nothing on top, so you put a 1 there. Okay, next one. It's another power to a power, so I'm gonna have to distribute. So give the 3 its 1 and then distribute this negative 3. So it turns into 3 to the negative 3, x to the positive 12, y to the negative 6 after I multiply those exponents. And then you have to move the things with the negative exponent. So 3 to the negative 3 goes to the bottom and becomes 3 to the positive 3. Same thing with the y negative 6. It becomes y positive 6. And then the only other way I'd clean this up a little bit is I would do 3 cubed, which is 27. Just like this. Okay, the next one, the top has a power to a power, so go ahead and distribute it. So I'm multiplying these, so it becomes 4 squared m8 over 20 m2, just like that. Now, 4 squared is 16, so I'm going to change this to be 16. All right, and now you have to reduce. So 16 and 20 are both divisible by 4. So divide them both by 4 to reduce them. And so when you go to write your answer, you have 4 on top, you have a 5 on bottom, and then comes the M8, M2. Well, the top is bigger by 6. So that's how I would answer that. Okay, the next one is a big multiplication problem. So basically, you can multiply these numbers first. 7 times 6, or 7 times negative 6 is negative 42. Times 2 is negative 84. Now, with these letters, like x4, x2, x, you're adding those exponents. It's only power to a power, like this, when you multiply exponents. If you don't have power to a power, you're probably going to be adding those exponents. So what you do is you give everything its exponent, like this x was missing a 1 there. And then you just add them up. So x4, x2 makes x6, plus x1 makes x7. y5 and y4 makes y9. And then you also had z3. Okay, this next one is a power to a power. So I'm going to be multiplying these exponents. So it's going to turn into -5 cubed x6 y9 z3. And then I would just do the -5 cubed, which is -125. Like that. Okay, number 7. I would move the negative exponent first. So a -2 is going to come to the top and become a +2. All right, so really what you have is 25 on top, 40 on bottom. A4, A2 on top is going to make a 6. And then B5 on top, B9 on bottom. The B is bigger on bottom by 4. And so you're basically done here. You just need to reduce the 25 and the 40. These are both divisible by 5. So divide them both by 5. And you get your answer, 5A6 over 8B4. Okay, this next one, give the -7 its exponent. It's a power to a power, so you have to distribute. So it's really like -7 squared x -4 y 16. And so -7 squared is 49. And then this x -4, imagine it over 1. It has to go to the bottom and become x +4. And then I had y 16 on top. So this would be my answer. Okay, moving right along. For a lot of these next problems, I'm going to be breaking down the number, and I'm not going to show my work for it after this. So let me show you one of them, and then we'll move on. Imagine you had to break down like 162 here. You start out by saying like 2 times what? Well, that'd be 81 times 2. And then you go, okay, well, 2 can't go into it anymore. Can 3 or some other small number? So 81 is 27 times 3. And 27 is 9 times 3. And 9 is 3 times 3. And 3 is 1 times 3. You keep going until you hit 1 on this left side. And then the right side's your answer. So it was 2 to the 1, 3 to the 4. Okay, that's how you break down those numbers. That's how I'm going to be doing this. So here we go. If you break down 24, you will get 2 cubed times 3 to the 1. Then I had x3, y7, z1. This is a square root. Okay. You have to take letters and numbers out of this root. And you can only do that if you have at least 2 of them. You have to take them out in groups of 2. So you're sitting there with 3 2s. It means you have one group of 2 that you could have taken out. And there would still be 1 left over in the root. Look at the 3s. You do not have a group of 2 that you can take out, so it stays. Look at the x's. You have 3 of them. That means you can take out one group of 2, and there would still be 1 left over. Look at the y's. You have 7 of them. That means you can make 3 groups of 2 and still have 1 left over. And then z1, you can't take out a z. All right, so I'm basically done here. The only other thing I do is multiply the 2 times the 3 under that root to make 6. So that's how you do those. All right, let's look at this next one. 48 is 2 to the 4 times 3 to the 1. Then I had A40, B50. and it's a square root. All right, so you're ready to do this whole process again. And basically you say, okay, how many groups of 2 can I take out? Well, there's 4 of these. That means 2 groups of 2 with no leftovers. Now there's only 1 3, so you can't take out the 3. There's 40 A's. That means you can make 20 groups of 2. There's 50 B's. That means you can make 25 groups of B with no A's or B's left over. So this is basically my answer, but I would take it a little further and be like, okay, 2 squared is 4. So it's 4A 20, B 25, root 3. Okay, the next one. Break down 81, you'll get 3 to the power of 4. It's a cube root this time. That means instead of making groups of 2, we're making groups of 3. So you can make 1 group with the 3's with 1 left over. You have 5 M's. That means you can make 1 group of 3 with 2 left over. And you have 9 N's. That means you could make 3 groups of 3. So this would be my answer. Okay, 162, we said was 2 to the 1, 3 to the 4. All right, now we're making groups of 4. So, see, groups of 4. So that means you can make no 2's can be taken out. But you can take out a group of the 3's because there's 4 of them there, and you're making groups of 4. M11, that means you can make 2 of them with 3 left over. And N6, you could make 2 groups. 2 groups. You can only make 1, sorry. And there would be 2 left over. Just like that. This would be my answer. Okay, 108. 108 is 2 squared times 3 cubed. We're making groups of 3. So you can take out a 3, 3 X's, 3 Y's, and left over would have been the 2 squared, none of the X's, and 1 of the Y's. And then to clean this up, I would just do the 2 squared part. You know that's 4. So this would be my answer. Okay, 225. I think that's 3 squared times 5 squared. You're making groups of 2 here because it's a square root. So you can take out a 3, a 5, 7 A's, oops, 7 A's, and 6 B's with just 1 of those A's left over. And then I would just clean it up a little bit. 3 times 5 is 15. Just like that. Okay. So these you can either break them down first or multiply them and then break them down. It doesn't really matter. But if you wanted to break it down first, this right here is 2 squared times 3 to the 1, and you're timesing by the root of, this is 2 to the 1 times 3 to the 1. So you can multiply these roots and add those exponents. So it'd be like 2 cubed 3 squared when I add those exponents. And now it's the same thing. You're taking out groups of 2. So you can take out a group of 2 from the 2's and a group of 2 from the 3's with 1 of those 2's left over. And then I would just clean this up. 2 times 3 is 6, so it's 6 root 2. Okay, 15 is 3 to the 1 times 5 to the 1. So now I can add the exponents within these roots and make it all into 1. So it'd look like this. 3 squared, 5, 1. x1, x3 makes x4. y2, y4 makes y6. It's a square root, so you're taking out groups of 2. So you can take out a group of 2 from the 3's, 2 groups of x's, 3 groups of y's, and left over was that 5. Okay, this next one. I would break it down first. So 2 to the 1 times 3 squared. And then 72, I think it's 2 cubed, 3 squared. So now the 4 times the 3 is going to happen outside. And then the roots, under the root, you're adding the exponents here. So it makes 2 to the 4, 3 to the 4. Okay? So you have the 4 times the 3. And then you're taking out groups of 2. So you can take out 2 of the 2's and 2 of the 3's. So really this problem turns into 4 times 3 times 2 squared is 4 times 3 squared is 9. So 4 times 3 is 12. 12 times 4 is 48. 48 times 9. Was that 432? That would be my answer. Okay, 1 page done, 2 pages to go. Okay, this next one. Break down the numbers. Make it all into one root by adding those exponents. Then take out groups of 3. Just like that. Okay, the next one, same thing. Break down the numbers. I think that's 2 to the 6. Make it all 1 and combine those exponents. Make groups of 4. And then you know what 2 squared is, so clean it up a little bit. All right, now we get into some FOIL with the roots. You can do it FOIL, you can do it double distribution, same thing. Basically, you've got your first times your first, root 7 times root 7 is just 7. The root goes away. Then you got your outside, inside, so that's minus 6 root 7 minus 6 root 7. And then you've got your last, negative 6 times negative 6 is plus 36. So now you combine like terms. 7 plus 36 is 43. And then negative 6 root 7 minus 6 root 7 is negative 12 root 7. Okay, the next one's the same thing. This FOIL, though, it's a nice one because this is kind of like a difference of squares. So you do your first times your first, which would just make 3. Then the outside, inside are going to cancel, but I'll write it out to show you anyways. You'll have a minus 5 root 3 and a plus 5 root 3. And then your L of your FOIL would be 5 times negative 5, which is negative 25. So these guys cancel, and you really just have 3 minus 25, which is negative 22. Okay, this one, it might help you to, sorry, that's a root, write it out. like this. That's what it means when it's squared. There's just two of them there. Now FOIL it out. The root 3 is just going to make 3. Then you're going to have the outside, which is root 3 times minus root 2, which is minus root 6. And then the inside's minus root 6 as well. And then the L is negative root 2 times negative root 2, which is going to be plus 2. So you end up with 5 minus 2 root 6s. Okay, and then the next one's kind of like a difference of squares as well. The first is going to make 7. The outside's going to make plus root 21. The inside makes minus root 21. And the L makes minus 3. So really you just have 7 minus 3, which is 4. Okay, now the division ones, you can either break them down or you can just divide it first. This one I would probably divide first. You would get the cube root of 32. And now you could break down 32, which is 2 to the 5. And then you would take out groups of 3. Like that. Okay, the next one I would probably divide it as well. So 24 divided by 8 is 3. You have R7 over R2 makes R5. The top was bigger by 5. And then the Z's cancel. So it's really just this. So you're taking out groups of 3. So you can take out an R, but that's it. And there were 2 left over. Okay, the next one I would divide first. So I think it's 48, x6. Now break down 48. Let's see, I think that's 2 to the 4 times 3 to the 1. Okay, now you're taking out groups of 4, so you can take out a 2 and a group of x's, and then left over is the 3 and 2 of those x's. Okay, the next one I would divide first. So you have h12 over h6, the top is bigger by 6. J7 over J1, the top is bigger by 6. And break down 8, you'll get 2 cubed. Now you're taking out groups of 3, so you can take out a 2 groups of the h's and 2 groups of the j's. Okay, this next one, go ahead and divide. Break down 81. Then take out groups of 4. You could put 3 to the 1, or you could just put 3. Doesn't matter. I made it uglier by trying to clean it up. Okay, I'm just going to rewrite it. We'll just put 3. Okay, last page. Rationalizing the denominator is something you really see a lot more in college, but it's important to know how to do. Basically, you can't have a root on the bottom of the fraction. That's not good. So the way you cancel it is you just times by that root generally. Now, not always. So I'll show you what I mean by that statement, but it's going to be like this. So the top just becomes root 35 and the bottom just becomes 7. And now you don't have a root on your denominator, so it's good to go. Okay, this next one, I would hit it with a root 12x. So on top, it becomes root 60x over 12x. But you can't just assume that you're done. So you would have to break down root 60. Root 60 is 2 squared times 3 to the 1 times 5 to the 1. Which means on top, you can take out a group of 2's. And you're left with a 3 and a 5 in there. And that x. And it's over this 12x. And now that this 2's out of the root, it can reduce with the 12. So when it's all said and done, on top you have root 3 times 5 times x, which is 15x. And on bottom you have 6x. And you cannot cancel those x's because one's in the root and one is not. Okay, the next one. Times by root 2 over root 2 to rationalize the denominator. So you end up with root 54x over 2. Break down root 54. That's going to be 3 cubed times 2. So 2 to the 1 times 3 cubed. Okay, take out groups. So you can take out a group of the 3's. Inside you'll have a 2 and a 3 left over with that x. Now these 3 and the 2 can't reduce. So here you would be done, but I would clean it up under the root a little bit. You know what 2 times 3 is, it's 6. So that's cleaning it up. Okay, now here's what I meant when I said not always. You can't just times by 1 minus root 7 here. That won't work. What you have to do is you times by 1 plus root 7 over 1 plus root 7. And the reason why is because on bottom, it's going to make a difference of squares. So let's look at the bottom first. On bottom, it's going to make 1 times 1. The outside is going to be plus root 7. The inside is minus root 7. And the L, the last, is minus 7. You see how these roots are going to cancel, and I won't have any on the bottom of my fraction here. I won't have any roots. So it's going to be rationalized. Now let's look at the top. If you FOIL it out, you'll get 4 plus 4 root 7 plus 1 root 7 plus 7. So 4 plus 7 makes 11. 4 root 7 plus 1 root 7 makes 5 root 7. This would be my answer. And I thought that was the last one. Okay, it's not. This next one, same thing. You're going to hit it with a 2 minus root 5 to rationalize that denominator. It only really applies for the binomials. All right, so on top, you're going to have 6 minus 3 root 5 minus 2 root 5 plus 5. And on bottom, you're going to have 4 minus 2 root 5 plus 2 root 5 minus 5. So that turns into 11 minus 5 root 5 over these cancel, and it just leaves 4 minus 5, which is negative 1. So this would be my answer. Advanced mathematicians, if you wanted to basically divide both of these things by negative 1, you could. This answer is the same thing as negative 11 plus 5 root 5. Okay, and now the last ones. You're adding and subtracting these radicals. So in order to do that, you need to have the numbers in the root all the same. So 2 plus 6 minus 1 is 7. So this one's just 7 root 5. I'm just basically adding these lead coefficients. All right, but generally they are not going to give them to you already all perfect, ready to go. So you're going to have to break down some of these and take out some groups and see if you can get the number in the root to be by itself. So like this one, 32 is 2 to the 5. 8 is 2 to the 3. 50 is 2 to the 1 times 5 to the 2. So take out your groups. You'll have 2 to the 1. You can take out 2 groups from this first root. with one thing left over. You can take out one group from this next one with one left over. And you can take out a group of 5s with one left over. So really, if you do this, if you multiply it out like this part, 2 times 2 squared, well, that's 2 times 4, which is 8. 5 times 2 is 10. 3 times 5 is 15. So really, it's like this. 8 plus 10 is 18, minus 15 is 3. So my answer is 3 root 2. Okay. Now this next one, you would need to first break down this guy right here. So it's like root 7x minus, this is 2 squared times 7 times x. So now you could take out a group of 2's. Now the things in the root match. So it's like 1 root 7x minus 2 root 7x, which is negative 1 root 7x. You could just put negative root 7x. That's an acceptable answer as well. Okay, almost there. Break down these numbers. Okay. Take out your groups. You're making groups of 2 here. Clean it up a little bit. So you have 9 root 2 minus 2 times 2 is 4 times 3 is 12 root 2, which is negative 3 root 2. Okay, same thing on this next one. All right, take out your groups. So it's really like 3 cube root 3 plus 2 cube root 3, which would make 5 cube root 3. Okay, and then this last one, same thing, break down the numbers. Okay, you're taking out groups of 2. Okay, clean it up a little bit. So you have 15 root 5 minus 14 root 5, which makes 1 root 5, plus 2 root 5 makes 3 root 5. So there you have it. There's the test review for test 5B, and I hope this video helped.